Yo, well, we might as well do a recent statistics paper as well. Got the mark scheme, got the formula sheet, got my good attitude, and my uh, a bit shaky love for statistics. Oh, I just spat everywhere. It's a good way to start. Anyway, I'll be respectful and take my gun out. See, man's about some respect. Got some respect, dude. Okay, let's do it. It's 2022 paper. And let's jump right in, baby. Woo! Find the number of different arrangements of the 8 letters in the word deceived. Something you should never do is deceive others, in which all 3 E's are together and 2 E's are together. Well, this is permutations and combinations. So we got the 3 E's together. So I'll put that in a little single slot. And we got the 2 D's together. It's another slot. So that's 5, and then we've got 1, 2, 3 letters left, right? And so this thing will just be 1, 2, 3, 4, 5 factorial. We rearrange all these 5 factorial ways. That'll be the number of ways in which all the E's will be together, because we're considering it as one block, and all the D's will be together. So 5 factorial, which equals 2. 120 ways. Find the number of different arrangements of the 8 letters in the word deceived in which the 3 E's are not together. Well, the 3 E's, I guess there's a few ways you could think about this. Let's do it like, well, the 3 E's not being together will be the total arrangements minus when the three E's are together. So, you know, number ways E's not together is equal to total number of ways, total number minus of ways minus number of ways when together. Probably don't need to write that, but okay, so well, total number of ways, total ways. Stuff can be arranged. Well, it's just going to be 8 factorial divided by 3 factorial for the E's, the arrangements of E, because of this idea of overcounting. Look at my permutations, combinations video. And times 2 factorial, right, for the 2 D's. So that's going to be 8 factorial divided by 3 factorial times 2 factorial. 360. 360 ways. And what are the number of ways when E's are together? Handwriting's pretty crap right now. Well, this is just similar concept as up here, but we just keep the E's together. So E, 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 that's 1. So that's 3, and then we have 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. So then 5 more letters, right? Remember, we have 2 D's in here, so it's the number of, so it's 1, 2, 3, 4, 5, 6 factorial, but divided by 2 factorial because we have these 2 D's here, and it's that idea that we're overcounting because the D and D represent the same combination, or same permutation or combination. Okay, so 6 factorial divided by 2, which is 360. 360 ways. So therefore, number of ways when is not together will be equal to 360 minus 360, which is 3,000 ways. Check that. Question 1. Okay, so 120 ways, yep. And 3,000 ways, yep. Cool. Okay, question number 2, baby. There are 6 men and 8 women in a book club. The committee of the club consists of 5 of its members. Mr. Lan and Mrs. Lan are members of the book club. Okay, so we have what? 1, 2, 3, 4, 5 nameless men, and we have, let's call Mr. Lan LM and Mrs. Lam LW, L man, L woman. And then we have 1, 2, 3, 4, 5, 6, and 7, right? That consists of the 8 women and 6 men. In how many different ways can the committee be selected that exactly one of Mr. Lan and Mrs. Lan must be on the committee? Well, this can happen 2 ways, right? If Mr. Lan is on the committee, then we have 1, 2, 3, 4 separate slots, right? Or if, so this is like fixed, right? Or the case when Mrs. Lan is on the committee, which is 1, 2, 3, 4. And so how many ways can this occur? Well, that Mr. Lan's on that committee. Mr. Lan. Well, for the first selection, we have 12 members left, 5 men and 7 women. So it'd be 12 for the first one times 11 for the second one times 10, right? Because we have then 11 left, and then 10 left, and then times 9, but then divided by 4 factorial, right? Because we're overcounting. You know, if we put man 1 here, or man 1 here, 1 here, or man 1 here, like they're all the same committee. So we're overcounting by 4 factorial, this arranged. And this will be the same thing here. Divided by 4 factorial. And then we'll just add those 2 together to get total. 12 times 11 times 10 times 9 divided by 4 factorial is 495 times 2 is 990. So this is 990 ways. In how many different ways can the committee be selected if Mrs. Lan must be on the committee? Man, she's getting some serious privilege here. She must be like really good at reading. And there must be more women than men. Okay, so we need to look at the scenarios in which that happens. Well, you know, Mrs. Lan, she is definitely on that committee. And so the ways, and then we have 1, 2, 3, 4 more slots, right? Because the committee consists of 5 people. Well, the ways that can happen is, well, if we have 2 women selected here, then we're going to have 3 women because Mrs. Lan is a woman. So then we have 3 women, which is going to be more than 2 men. So it can happen if we select 2 women. It can also happen if we select 3 women for these final 4 slots. And obviously it could be also 4 women for all of the slots. How many ways can this happen? Well, we're selecting 2 women from 7. So another way to think about it, 7 times 6, right? 7, 6, and then divided by, obviously, women 1, women 2 is going to be the same committee as women 2, women 1. So we need to divide by 2 factorial. Multiplied by the selection of then 2 men, which will be 6, because we still have Mr. Lan. So it'd be 6 times 5 divided by 2 factorial. And if you put that in, you get 7 times 6 times by 6 times 5 divided by 2. 315. 315 ways. And then for 3 women, well, we're selecting 3 women, so 7 for the first one times 6 times 5 divided by 3 factorial times by, well, 1 selection from 6 men will just be 6. 6 over 1 factorial, I guess. That'll be some. 3 factorial is 210. 210 ways. And for 4 women, well, that'll be 7 times 6 times 5 times 4 divided by 4 factorial. And we have no men, so we don't have to worry about that. 7 times 6 times 5 times 4 divided by 4 factorial is 35. Right, so if we want the total ways for these 2 restrictions here, where Mrs. Lan is on the committee and also there's more women than men on the committee, we just need to add all these things up. So get 315 plus 35 plus 210. It's 560 ways. So total will be equal to 560 ways. Boom. I guess we should check that. So 990. Yep. And 560. Cool. The times taken to travel by college by 2,500 students are summarized in the table. Okay, draw a histogram. Well, a histogram will be frequency density against time. So we need to find the frequency density for all of this. The way I remember this, well, frequency density is the area, will be the area of these histogram blocks, or whatever you want to call them. So, you know, this area here is the frequency. So the frequency, you know, the frequency equals to the frequency density times, you know, this width, the class width, they call it, or you can say time width. Yeah. So the frequency density is just the frequency over the time width, let's call it. So for this first one, it'll be, just divide this up. So we're just graphing this. So we're dividing this up. So it'll be frequency is 440 divided by 20. The first one will be 22. The next one will be 720 divided by 10, which is 72. 920 divided by 10, this width is 10, so it's 92. And then 300 divided by 20 is 15. And 120 divided by 30 is 4. Okay, so then we just need to graph that. Do you want me to do it? Okay, fine, I'll do it. Okay, so we're going up in like 20, 40, 60, 80, 100 will be good. So 20, 40, 60. I'm going to do this really quick to save on time. 100. And then 20, 40, 60, 80. Is that going to be enough? Yeah. 100 at the bottom. Okay, so 0 to 20, 0 to 20. You can do it better than I can. So each of these ones are 2, no? Yes. Oh god, this is gonna be so bad. So this is the first one. Don't laugh at me, okay? Get the idea. Okay, that's for 20. Maybe I should have done 10s, but whatever. Wait, 10, 20, 30, 40, 50, 60. Now we don't have enough room with that. Okay, 20 to 30. This is 30 here. And this is 72, which is... you get the idea. 72, which is here. Okay, so this goes up. You get the idea. No. No. The struggle. Okay, that's at 72. And this is width 10, so this is the 20 to 31, and then the 92. 92 will be here, and this is from 30 to 40. So this is the 92. God, bro. Whatever. 92. And this is 15 for the 40 to 60. 40 to 60 is 15, which is like 2, 4, 6, 10. It's like roughly here. And then 120 is 4 from 60 to 90. So 90 is here. So 424 is like this. Okay, I'm just gonna look. Okay, boom. Okay, they did it. It's the same thing, but mine's obviously not very well drawn. Okay, so that's how you do it. From the data, The estimate of the mean value is, so the estimate of the mean is 31.44. Calculate the estimate of the standard deviation. So standard deviation, this is grouped data, right? So we can use this, right? For grouped data, we can use this. So it'll just be equal to the sum of, it'll be this, so it's grouped. So I'll just write out the formula, I guess. Be square root of the sum of x squared. I might not do all of this calculation just to save on time. Over n, the sum of all the frequencies, which would be n in this case, minus the mean squared, so minus t. So this will equal to, you know, x squared. So, and this is the middle of the frequency. So, you know, it'll be x squared, which is the value. Well, no, x. Is this the right term, or t? So t, your t squared will be the middle value here. So halfway in this interval. So t is 10 for the first one. It's going to be, so the squared of t, just to take away the square root, will be 10 squared times the frequency of that occurring, which is 440, plus the next one will be 25, halfway between them. It's just 10, 20, 25. What? Halfway between 25 and 720. So then plus 25 squared, 720, plus 35, 990, 35, 920. 35 squared, 920, plus, and you know, all of this, plus, and it will be minus this mean squared, which is 31.44 squared, just to note that, plus, why do I keep going too far? 50 squared times 300. I don't know if it's worth me doing this. It could be like a waste of time. Plus halfway between that and that is what? 75? Brain. Yes, 75 squared 120. 75 squared 120 divided by n, which was 2000, right? 2500. 2500. And you plug all that into your calculator and then square root it, and you'll get an answer. But I'm just going to look at the answer because I'm not going to take too long. But look, yeah, 440, 10 squared, you know, to 120, 75 squared. So exactly what I did here. And then minus the mean. And you'll get an answer of 15.2. So you square root this and you get 15.2. So just plug all that into your calculator and square root it and you'll get the answer. But I'm trying to keep everyone engaged. If the video's too long, people drift away. In which class does the interval have upper quartile lie? The upper quartile is the 25%, top 25% point, right? And so we have 2,500 students. So the top 25, the 75th percent, or whatever you want to call, just do. So this times 0.75 give us the point. So it's 1875. Where does that occur? At what interval? Well, 440. So 440 and plus 720. So that's 160 students here. And then for the next one, it's plus 920. So this, in this interval, the 187th student lies. So it's the between 30 and 40. So the interval 30, 40. Yeah. So this interval. It was later discovered that time taken traveling with students were incorrectly recorded. One student was recorded 15 instead of 5, and the other was recorded 65 instead of 75. Without doing any further calculations, state whether the estimate of the standard deviation part B would increase, decrease, or stay the same. 15 instead of 5, and 65 instead of 75. Well, it's going to stay the same, no? So it's going to stay the same. Because these all lie, this whether it was 15 or 5 doesn't matter, because both these points lie in that first interval between 0 and 20, so it's going to be recorded as a frequency point between that, and same with 75 and 65. Those both lie in the 60 to 90. Right, so it doesn't matter if they change, because it's still going to be recorded within this interval and this interval. So it doesn't matter, so it will stay the same. Right? So 30 to 40, yeah. And it stays the same. Data still in the same intervals. Boom. Okay, let's continue. Jacob. We got to get this one right. We have to. Just out of necessity. Jacob has 4 coins. If Jacob had 4 coins, Jacob would probably go out and party or something. If Jacob had 4 coins, that's a lot of coins. What the fuck am I talking about? Okay, Jacob has 4 coins. One of the coins is biased, such that when it's thrown, the probability of turning head. Okay, so let's say probability of head. I'm gonna call it dash. So this bias coin. So the dash represents this bias coin. 7/10. And so obviously tails would be 3/10. 3 other coins are fair. Jacob throws all 4 coins. What a baller! He just throws it all. The number of heads that he obtains is denoted by the random variable x, probability distribution. The table follows this. Show that A is 1/5 and find the values of B and C. Well, A is when we get 1 head, so probability is the number of heads. Okay, so the probability that we get 1 head, right, is going to be equal to, well, what are the ways that can happen? It'll be, so let's say we probability, so we need to consider our biased coin. So let's say we roll, we get a head, we could get a head with the biased coin, and then we'd have 3 tails, right? That's one way. But another way would be, well, the biased coin goes on a tail, and then we get 1 head in here. All right, and that's the probability of us getting a head, right? 1 head. In both of these cases, we get 1 head. We're just considering the biased coin because it has a different probability. So what are these things equal to? Well, for this one, well, the biased coin is 7/10 times 1/2. Well, the probability of a tail, because it's not biased, it's going to be a half cubed, right? Because we've got 3 of them. And plus the probability of a tail on the biased coin is 3/10 times, again, 1/2 cubed. But this can happen, this can be arranged. We could roll a tail and then a head and then a tail, or we could roll a tail and then a head, or we could roll, so it could be 3 different ways. It could be this way, when the head is in the middle, or when the head is at the end. So we have to multiply this probability here by 3. So this should equal to 1/5. 7/10 to the power of times 1/2 to the power of 3. That's 780. 7/80 plus 0.3 times 1/2 to the power of 3 times 3. That's 9/80, which equals plus 7/80, which equals 1/5, which is what they wanted, right? Yeah, 1/5. So A equals 1/5, shown here, and I guess we'll be doing the same things again, but for 2 heads. 2 heads, well, let's take into consideration we get a head for the bias coin. Well, then we have a probability of head and 2 tails, plus, so we get a tail, and then we'll have head, tail. Well, this is just going to be the same as this. Same as this, because we arrange this 3 times, same as this, arrange this 3 times. So it's going to be 7/10 1 squared cubed times 3 plus 3/10 1/2 cubed times 3. That equals 2. The 3/10 one is 9/80. What is it? 7/10? 7/80 times 3 plus 9/80. It's 3/8. This equals 2. So this equals to 3/8. So B is equal to 3/8. And C will do the same thing again, but for 3 heads. So consider we get a head for the bias coin, then head, and tail, plus tail for the bias coin, gonna be head, head, 3 heads, both those cases. Okay, and this equals 2. Well, this is going to be 7/10 times 1/2 cubed times 3, right? 3 different ways. Could get a tail at the end, middle, or start. And this one, well, this is going to be 3/10, and 3 heads. Well, we don't need to multiply by 3 there because there's no different arrangements. Head. Switch them over. Head. They're all head. This is just 1/2 cubed. And that equals 2. What was 7/10? This was 7/80. So it's 0.3 times 1/2. Ooh. That plus 7/80. No, what was 7/80 times 3? Plus 0.3 1/2 3/10. 3/10. So C equals 3/10. That's your A, B, and C. Find the expected value. It's just from your formula sheet. So I should just check those real quick. 3/8, 3/10. Yeah. So from your formula sheet, for discrete random variables, this is the expected value. So the sum of the probabilities, x is the probability, so just go through them all. So it'd be 0 times 3/80 plus 1 times A, which is 1/5, plus 2 times B, which is 3/8, plus 3 times 3 over 10 plus 4 times 7 over 80 times 7 over 80. And then you plug all that in to your calculator. You get 1 over 5 plus it's 6 over 8 plus 9 over 10 plus 4 7s 28, 28 over 80. So you get 2.2. 2.2. Jacob? Man, this is such a beautiful name, don't you think? It's a biblical name. Jacob throws all 4 coins together 10 times. Find the probability that he obtains exactly 1 head. So this is binomial distribution. So the probability of success is that he obtains exactly 1 head. And what is that? Well, 1 head was A, so this is 1 over 5. And the probability therefore of failure will be 4 over 5. Okay, and n is 10. So I guess we write x is the number of success in 10 trials. And so we want the probability that x is fewer than 3, which is going to be the probability that x equals 0 plus the probability that x equals 1 plus the probability that x equals 2. And well, you can plug that into that formula here. So for 0 successes, it'd be 10, 0, 1, 5, 0, 4, 5, 10 plus 10, 1, 1, 5, 1, 4 over 5, 9 plus 10, 2, 1, 5 squared over 5, 8. That equals, I'm not going to calculate that. Yep. That's exactly what I got. 10C2, 1 over 5 squared, 8. It's exactly what I got. Yeah, that all together you get 0.678. You just plug all that into your calculator. I'm just trying to save on time. Okay. And find the probability that Jacob obtains exactly 1 head for the first time. So this is geometric. I also have a video on this. So now x is number of trials for success in 10 trials. Well, the geometric distribution will obtain 1 head, or the probability of success, not the probability of sex, is, oh wait, not in 10 trials. Find the probability that Jacob obtains exactly 1 head for the first time. The 7th, oh no, it is 10 trials. That he throws the 4 coins. Okay, so this is this, and this is going to be, we want the probability of x equaling 7 or x equaling 8. And that's just going to be from your geo is this. So the probability of success times the probability of failure happening on the 7th trial is 7 minus 1, which is 6, plus 1, 5, 4 over 5, 7. And so therefore the probability will be 4 over 5 to the power of 6 plus 5 to the power of 7 . I'm just plugging this into my calculator. 0.944. 0.944. Okay, let's check those answers. Yep. Oh, 0.9. Oh yeah, 0.9, sorry. Read it wrong. 0.944. Okay. Find the length in centimeters of, so this is going to be normal distribution. Find the length of centimeters of a particular, the length of centimeters of leaves of a particular amount. So X is length of leaves in centimeters. X is normally distributed 5.2.5 squared. Find the probability that a randomly chosen leaf of this type has a length of less than 6. Probability that X is less than 6. Well, just sketch this real quick. Got this mean is here. 6, so less than 6 will be this. So the probability of this will be, we want to find our corresponding z value, which is x minus mu over lambda, which in this case is 6 minus 5.2 divided by 1.5, which equals to 6 minus 5.2 divided by 0.533. 0.533. Therefore, so the probability that x is less than 6 is equal to the probability that z is less than 0.533, which equals to this in the standard notation. Then you just find that on your graph, on your table. So 0.533, 0.533, 3 is add 10, so 0.7029. So it's equals to 7029. So the probability that x6 is equal to 0.7029. Okay, let's be checking these. 703, so they round. Okay, I guess you have to round. Okay. Find the lengths of leaves of another type are also modeled by a normal distribution. A scientist measured the lengths of the randomly sampled 500 leaves of this type and finds that 46 are less than 3 centimeters long and 95 are more than. So the probability that x is less than 3 is equal to 46 over 500, which is 0.092. 0.092. Probability that x is greater than 8 is going to be 95 divided by 500. 95 divided by 500 is 0.19. Okay, I'm just jotting down what they tell me. Find estimates for the mean and standard deviation of the lengths of the leaves of this type. Well, let's have a look here. So remember that z will equal to x minus mu over standard deviation. So for this first one here, so we want to find the mean and standard deviation. So we need to set up equations. We need to have two equations relating to the mean and standard deviation. So for this first one, we have 3. So in z, so let's say z1 here. We want to find this corresponding z value to this 3. This area is 0.092. So then this, I guess, will be z1 will be this, which is going to be 1 minus this. 1 minus 0.092 is 0.908. So this is 0.908. So our Z1 is going to be minus whatever this is. So, you know, so Z equals to, from here, we can find this on the graph, but it's going to equal to 3 minus mu over lambda, but what Z value gives 0.908? So so what value gives an area of 0.908? 0.90, so 1.32 plus 14. So we'll give us 0. So it'll be 1.329. So this Z value corresponding to this area is 1.329. So the Z1 here for this 3 is going to be minus 1.329, right? Because it's on the other side. This is 0. We have to find here so we could find the corresponding Z values, because this is for the positives. So we're just using the symmetry of the graph. So this equals to 3 minus mu over lambda, over standard deviation. So that's one equation relating mu and the mean and the standard deviation. Then we do the same thing with this other one. So the probability, so Z2, this area is for 8. So I'm finding the corresponding. I hope it's clear what I'm doing. Like, this is 8 for x, and this area is 0.19. And so this area is 0.81. Yeah? So the corresponding Z value we need is Z2 with an area of 0.81. So what Z is going to give us 0.81? Well, Z2, which remember will equal to x, which in this case is 8 minus mu over lambda. Well, Z2 will equal to, what is it? 0.81. 0. Plus 5. So it's going to be 0.845. 0.845. Okay, so therefore we have another equation, 0.845 equals 8 minus mu over lambda. So that's another equation. And then we can now solve them. We have one equation and two equations. Okay, so let's make this look nicer. We don't have much room here. So we have two equations and two unknowns, so now we can just find them. So, one, we get minus 1.329 lambda equals 3 minus mu. So mu equals to, take that over, we get 3 plus 1.329 mu. We can then substitute this into here. Or we can rearrange, let's rearrange this as well. So we get 0.845 lambda equals 8 minus mu. So therefore we get 0.845 lambda and mu equals 8 minus this, which is 3 plus 1.329 mu. 8 minus 3 is 5. So this gives us 5 minus 1 point. So we're going to take that over. It'll be a plus. So it's 0.845, 0.845 plus 1.329, 2.174. So this is 2.174 lambda. So lambda equals to 5 divided by this, which is 2.2999, or 2.3. And our mean, therefore, will be, if we substitute this into here, we'll get this times 1.329 plus 3. 6.06. 6.06. Let's check that. It's a little difficult, I think. 2.27. Okay, I rounded too much. But they got. Oh, they're cool with it. 2 point. So, I guess you. Okay, I guess in statistics you have to keep everything to 2dp. Okay, so this was like 2.28, I'm pretty sure. .01 minus 1.329. Yep. And 0.878. 0.878. 845. Why did I get that? 0.845. I got that from 0.81. 0.81. 0.87. Maybe I possibly did this wrong. 95. 878. 0.878 gives a value of 878. Oh, that'll be 81. Okay. I put it in wrong into the graph. This is actually 81. 7, 8. I missed the exact point on the graph. But if you do that, you'll get different values. So that's why I was off a little bit. I was a little bit confused by that. Anyway. So this is 2.27. You'll get 2.27 there. And you'll get mu 6.01. So I guess that's an important lesson. Make sure you take your time with that, with checking these numbers in this graph. It's pretty easy to make a small mistake, which I did there. Okay, in a random sample of 2,000 leaves of the second type, how many would the scientists expect to find with length of more than 1 standard deviation? Well, so we're wondering, so minus a standard deviation, what's the probability? Or like what does this area equal? These two areas equal together? Well, in the standardized form, because z equal to 1 is 1 standard deviation from the mean. So this is the same as saying this for z is 1, and for z is 1 minus 1. So the probability to expect it to be more than 1 standard deviation from the mean for these leaves is the probability that z is less than -1 plus the probability that z is greater than 1. And this is the same as saying the probability that z is greater than 1 due to this symmetry of the curve. Oh, I'm hungry. That's the probability that z is greater than 1. And this is the same as 1 minus the probability z is less than 1 plus the same thing here. 1 minus the probability that z is less than 1. We do that because this is the thing we can actually calculate from that table. So this would be 1 minus this plus 1 minus this. So that's 2 minus this. 2 minus 2 of this, which equals 2. What is this? Well, when z is 1.0, we get 0.8413. So 2 minus 2 times 0.8413. 2 times 0.8413. 2 minus answer is 0.3174. So this equals to 0.3174. And so therefore, the expected number will be, the expected amount will be 2000 times, because this is like for the probability of 1 leaf, so we want to know for 2000 will be this times this. So times 2000 is 634.8. 634.8 leaves are expected. So yeah, I guess we'd have to say like the actual number. Yeah, so six, you could say 634, 635. It's really rough. 634. I'm just gonna take a quick, so that's right. I'm just gonna go to the toilet real quick, and I'll come back and do this. Okay, let's finish this mofo up, baby. Okay. Janice is playing a computer game. She has to complete level 1 and level 2 to finish the game. She is allowed at most 2 attempts at any level. 2 attempts at any level. Okay. For level 1, the probability that Janice completes it at the first attempt. Okay, so we're gonna have to draw some tree diagrams here. Okay, so for the first attempts at these levels, for level 1, call this, if she succeeds level 1 or she fails level 1. So the complete is, level 1 is 0.6 if she succeeds, so therefore 0.4 for her to fail. If she fails at the first attempt, the probability that she completes the second attempt is 0.3. Okay, attempt, so this is attempt 1. We'll say this is attempt 2. Let's call it S1 dash. So I'm just like S1. I'll do a dash. So the dash indicates that it's a second attempt. Or fail 1 dash will be that she completes it on the second attempt is 0.3. 0.3. 0.7. Okay, if Janice completes level 1, then she immediately moves on to level 2. For level 2, the probability that Janice completes it on the first attempt. So for level 2s on the first attempt, so I guess you could do like, this is start of level 2. So if she succeeds on level 2, here's 0.4. So therefore she fails on level 2 is 0.6. If she fails at the first attempt of level 2, well then she'll move to the second attempt of level 2. The probability that she completes it at the second attempt is 0.2. So, if she fails, then she's doing a second attempt here. Maybe this is a confusing way to do it. Oh, I don't know. It makes sense to me. It's going to be, she can move 0.2. and 0.8. So a first attempt at level 1, if she completes it, then she moves to level 2. And then if she fails, well then we're interested in this part of when she's attempting level 2 again. So this is the second attempt at level 1, and this is the second attempt at level 2. Second attempts. Attempt 2s. Attempt 1s. Show that the probability that Janice moves to level 2 is 0.7. So the probability that she gets to level 2. Level 2. This is equal to the probability. So what ways can she get to level 2? Well, she succeeds straight up. She just succeeds. Right? And then she's at level 2. Or she fails. And then on her second attempt, she succeeds. Right? Those are the 2 ways she can get to level 2. So this is 0.6 plus this is 0.4 times 0.3, which equals to 0.6 plus 0.4 times 0.3, which equals 0.72, which is what they wanted. Okay, find the probability that she finishes the game. Probability that she finishes. But we have the probability that she gets to level 2, and the probability that she finishes the game will be the probability that she gets to level 2 multiplied by the probability that she succeeds level 2 on her first or second attempt. So this is probability. So if she succeeds on her first attempt, well, this is just 0.4. So this would be S2 plus the probability of plus the probability, wait, hold on, so level 2, or she, so find the probability she finishes the game. So she's gone to level 2. So the first attempt, let's say, and then the probability of the second attempt she succeeds will be if she fails the first attempt and then succeeds. So it would be the probability she fails, so F2, and then succeeds on the second attempt, which should be this, according to my notation. So 0.72 times, you could calculate them all individually, but this actually is probably quicker. Be 0.4 plus 0.6 times 0.2. 0.6 times 0.2 plus 0.4 times 0.72 is 0.3744. So the probability she finishes is 0.3744. Okay, and lastly, find the probability that Janice fails exactly one attempt, given that she finishes. We have the probability she finishes, so the probability, if she fails exactly one attempt, well, that means that she either fails on the first level or second level, given. So that's right. If she fails exactly one attempt, it's the probability that she either fails on the first level or she fails on the second level of her one attempt. Given she finishes, which from that formula is the probability of them both occurring. So fails first or second, and finishes. It's the notation, and finishes, just like I want to finish this paper, divided by the probability she finishes, which we already have. So we need to find this. So what is this? So the probability that she fails on the first attempt. So the probability that she fails on the first attempt, right? And then finishes. So the probability she fails on the first attempt is 0.4. So wait, fails on the first attempt, and then finishes. Well, she's failed on the first attempt, so then she's on to her second attempt of the first level, which is 0.3, so it'll be S1 dash, and then she succeeds again. That means she finishes overall. Right? So she fails on the first attempt. Her second attempt, she completes level 2, and then, oh no, wait, and that'll be 0.4. Sorry. Right, so she fails on the first attempt. It's actually quite confusing. She fails on the first attempt, which is 0.4. She then succeeds on the second attempt of level 1, and then she goes to her first attempt of level 2, which is this. Plus the probability. Well, another situation will be if she fails on level 2, which would mean that she succeeds on her first attempt, but then fails on her second attempt. no, fails on her first attempt of level 2, and that means now she's proceeded to level 2, so now then she succeeds on her second attempt of level 2. So this is going to be, so success 0. Fail 0.4, then success, so 0.4 times 0.3 times 0.4. This one 0.4 times 0.3 times 0.4 plus, this is, I'm calculating this here, plus probability success fail. So success on the first attempt at level 1, fail on the first attempt at level 2. So 0.6 times 0.6, but then succeed on the second attempt at level 2. So 0.6 times 0.6 times 0.2. So that's that divided by this 0.3744. So this is 0.4 times 0.3 times 0.4 plus 0.6 times 0.6 times 0.2 divided by, so it's going to be 0.12 divided by 0.3744 divided by 0.33744. So 0.32 equals, so the probability of this thing is 0.321. Maybe they round. 321. Okay, cool. It's actually quite difficult, that one. Anyway, okay, that's it. Hopefully that was useful. Sorry for the couple slip-ups I may have made, but other than that, I think I did pretty good, and I hope it was useful. Like, subscribe, and I'll see you later. Bye.